you're given an equation and you want to find any maxes and mins that may occur. Well, we could do this algebraically, or we could do it using calculus or whatever we wanted to do there, but I'm just going to do it in the calculator because it's easier. So I'm just going to go to the y equals, we hit the y equals button here, and type in 2x squared plus 5, and hit graph. Now, at this point, we need to be able to find our graph. And I can see it all clearly already, so we really don't need to zoom around and find it. If you're not sure how to find a graph, be sure to look at my video on that. But for this, I think we can already look at it and know there is a minimum, not a maximum. A minimum occurs anytime it goes down and comes back up. Like that. A maximum would look like this. So clearly this one has a minimum. So once you've identified the minimum and you can visually see where it is, then we're going to go to the calculate. So second calc, and minimum is number 3. Notice that maximum is a different value. So you do have to know before you start, is it a max or a min? So min is number 3. And then we have a left bound. What that means is choose a value to the left of what you can see. So I'm going to hit left button, and it doesn't really matter what I choose. I'll just pick something right like there. It really doesn't matter, and hit enter. Now right bound means somewhere to the right. It doesn't matter where I choose as long as it's to the right of where I see. So somewhere over here, that should be good. So I'll hit enter. And then it wants a guess. So the guess just doesn't matter at all. It's giving it a place to start. So just hit enter again. You don't have to move at all. Now at this point, it gives you something kind of screwy. We have 8.5618 e minus 7 and y equals 5. Now this thing is a weird number. It means 0.000000, let's see, 7 zeros, 85618, right? That's what it means. That e means times 10 to the negative 7th. Well, this is pretty much 0. And in fact, the answer is exactly 0. The calculator, whenever you calculate things graphically like this, it's actually doing an estimation. So like if you look at our graph here, you gave a left bound and a right bound, something like this. And it's going to do some complicated stuff to narrow in on the minimum between those 2 points. And it's going to approximate that. It'll never get down to exact values. So that's why it gives you an approximation instead of a real value. In a lot of cases, it will just tell you directly 0. But if you see something like this times 10 to the negative 7th or something like that, just know it means exactly 0. So our answer here is 0, 5 is the minimum. All right, let's take a look at another one. This time, let's say we have the same thing, but it's just a negative 2x squared plus 5. So I'm going to go to y equals, and a little trick, you can use an insert. Most people don't know about this. You can just hit second and then insert, it's on the delete key, and then just type the negative. That way you don't have to retype everything, the whole thing, because it's all pretty much the same. I'll hit graph. And we see basically the same thing, but it's flipped. So in this case, you can see that it has a maximum. So I'm going to do basically exactly the same thing. The maximum is no different than the min, except you use a different option. So I'll go to the second calc, and this time we're going to hit number 4 for the maximum. Left means go somewhere to the left, enter. Right means go somewhere to the right, enter. And then the guess just doesn't matter, so I'll hit enter again. And again, we get some screwy e negative whatever. So that is just 0, as we discussed earlier, 5. So this one has a maximum of 0, 5. All right, let's take a look at another one. A little more tricky this time. Let's do y equals 100 x cubed plus 9x squared minus x plus 1. That's quite a bit more complicated, right? To do this algebraically would be very difficult. However, on the graph, it should be just pretty much the same as the last problem we did. I'll hit clear because these graphs are nothing to do with each other. So I'll type 100x to the third plus 9x squared minus x plus 1. And then hit my graph. Now, I don't know what's going on with that. That is too hard to tell. It kind of looks like there is no max or min, right? but we better make sure. So in this case, what I'm going to do is zoom in because it looks like something funny could be happening in the middle there. I just can't really tell. So I'm going to zoom in on this area I really can't see and hit enter. And now I can start to see, oh, there is a minimum. So I'm going to zoom in again. So I'm going to move down here, make sure that I choose a point that's right in the middle there and hit enter. Now I can start to clearly see that there is a maximum and there's also a minimum. So the maximum we'll find first. So I'll go to second calc, max, just like we did before, number 4. And I need to go to the left of the maximum for the left bound, and then to the right. Now be careful here. If you go too far, you can actually mess it up. If I come over here past this other minimum, funny things happen. Don't do that. I went too far. So for the right bound, make sure that you go right, but don't go past the other minimum. So when I hit enter here, it's that, and then guess again doesn't matter, so I'll just hit enter again. So this one gives me negative 0.095064. Now that's not an e-4, that's just kind of a nasty number. And y is 1.090486, whatever. But that's our max. If I want to know my minimum, well, I'll just do the same thing. I'm going to calculate the minimum between the left bound, so looking at my min, I go left of the min, but to the right of the max, enter. And I come over here to the right here, right bound, enter again. And it gives me 0.035, 0.98. Not very consistent on my rounding, but you get the picture. We have this value for the min, and we have this value for the max. And we did it entirely on our calculator.